Yeah, great. So thank you and welcome again to our 5th Kubernetes Australia Meetup tonight, hosted generously by Google. So before we begin, just like to quickly acknowledge the traditional lands on which we are gathered tonight. So we pay our respects to the owners of this land, the traditional elders past, present, and emerging. So what we have lined up for you today is a great agenda packed with amazing 2 topics. So first of all, my name is Louisa, and I'm currently studying Commerce and Computer Science at Monash University, and I'm really honoured to be your host tonight. And we'll go through the rest of the introduction. Then we'll move on to our very first topic tonight by Yann, which is about GitOps. And second topic will be from Kunal, from talking about GKE. Of course, very appropriate for the venue on which we are gathered tonight. And finally, if time permits, we'll have a raffle, some of our swags from CNCM, which will be followed by open mic and networking, and we'll ask for you to provide some valuable feedback. So if you don't already know, we also have launched on LinkedIn, and we have KSUG page, which is dedicated to all things related to our meetups all around the world. So we actually are now not only in Australia, our first meetup was in Singapore, but we also launched in Canada. So this is a quick thank you for our main sponsors for continuously sponsoring us throughout these events around the world. So Cloud Native Computing Foundation, of course, Google Cloud, CloudCasa, and we have JFrog. Thank you to our volunteers for your dedication over the course of our entire development, and hopefully many more months to go home. So we have Susan, Prasanna, Harrison, who is yet to arrive, and Tiago. So thank you deeply. And as always, we welcome more volunteers, sponsors, and speakers. So if you're interested in any of these roles, please reach out to us through these forms or come have a chat with us in person tonight. So for tonight, as I mentioned earlier, these are our respective topics and speakers. And just quickly announce our upcoming events. So these are across KSUG globally. So the next event we have is again hosted in Google, but all the way in Singapore. So that's on the 23rd of August, where, as with all of our events, we make them available online real time via Zoom, and also be uploading the recordings within 2 to 3 days. And that will be available on the YouTube channel. And after we successfully launched our very first KSUG Canada event in Toronto just last week, the following event will be coming up on the 14th of September. Again, that will be available online to be watched at any of your free time. And next month, we are planning for another event. So please keep your eyes posted. So this will be October and for our own Australian meetup. So that will be following our topics for tonight. So without further ado, I'd like to hand over to our first topic and speaker of the night, Yann. Thank you, everyone.
I also be on the Zoom, and then I go to the SU. That's the post. It's not that. It's not. That's the
Might looks like I can share.
No, I will stop it here. You share it. This is should I come up?
Yeah, let me do this.
Option. This way.
It is a quick code, no?
Okay.
Hi, good evening, everyone. My name is Yann. I'm going to give a short introduction to GitOps and Fluxcd especially. So just a tiny bit about me when that starts. Yes, cool. So I'm Yann. I'm French. I just arrived in Melbourne about 3 weeks or 5 weeks, 6 weeks. I lived in London for quite a while. And yeah, I'm still fresh off the boat. So I've been in technology for about 20 years, doing some dev and bit of ops. And I've been an entrepreneur at heart. So I've been building companies. The last one I've been working on recently is one which we're developing a solution for monitoring systems, for monitoring some voice over IP systems. So bringing some observability to something which is a bit old. And not really well monitored. And today I'm just going to introduce about GitOps and Fluxcd, which have been used quite a lot for this thing. Otherwise, if you want to connect with me, there's my LinkedIn profile. And yeah, you can bribe me with any of the thing that is at the bottom. So coffee, cheese, wine, and beers. I'm fine with any of these things. Cool. So let's start a bit with GitOps. So what is GitOps? So how many of you are using GitOps first? Or not many? Or how many of you are familiar with GitOps and heard of it? Okay, a bit more. Cool. So GitOps is a set of practices and tools for managing the infrastructure and deploying your application so the system is described usually in a version controlled environment. So it's declarative and in the source version control. So there's usually an automated process which is looking for what is happening on the Git repository as an example, and it's pulling the changes and making sure that it's reconciling and what you have described in your Git repo is what is happening in your production environment. One of the things that GitOps is promoting is using a pool-based deployment model. So what does it mean? So when you have usually a deployment pipeline, it usually looks like this. So you have your developer pushing the code into an application repository, Git as an example, that is going to trigger some build pipelines, which are going to build this thing, create some artifact at the back of it. So in our case, mainly a Docker image, and that's going to push this Docker image to a Git repository, or to an image repository. And probably if you want to do this still using some GitOps approach, you're going to have a cluster which is describing your application and how you want to deploy this, and that's just going to update the version. When you hit the cluster the repository, what is going to happen is that is going to trigger another pipeline, which is then going to contact your Kubernetes cluster and start deploying this. So usually it's going to do some kube apply or kubectl apply and read this thing. So that's good, that works well, but there's a couple of issues with this. And one of them is mainly around the security, which means you have inside your deployment pipeline direct access to your Kubernetes cluster, which is probably not something you want to have. So what is the pool-based model? So similar things. So your pipeline at the beginning is roughly the same, except that when you push to a cluster or your cluster repository, what is going to happen is inside your Kubernetes cluster, you're going to deploy an agent that is going to listen, or an operator, which is going to listen to your cluster repository for any changes, pull the changes, and it's going to reconcile this. So if you have described that you want one pod, it's going to spin up one pod. If you describe you want two pods, it's going to spin up two pods. Update the configuration. So it's going to observe what is happening inside your repository and inside your image repo as well. And then the operator is going to look at what is present in Kubernetes and start reconciling the stuff. Then you can have some options. So it's going to deploy your application or your whatever you want to do. And in return, it can potentially write things to the Git repo to say it's done or something happened. You can also use some webhooks to trigger this to be a bit more responsive, because the operator is just going to constantly pull the changes. So every 5 minutes, every 10 minutes. But if you want to, each time I make a push, change on my code and push it, that's going to go then trigger a Git webhook, which is then calling the operator, which is then assembling everything. So that's some of the benefits is for me for using GitOps practices is you're using the same tools as the developers mainly. It's usually Git, so you push everything inside Git, so you don't really need to use anything else. You do not need to use any command line with this, or that's not true. I'll show you some of the command line tools. But you usually don't have to know Kubernetes, do kubeapply and all this thing. It's going to be done for you. There's less drift in your configuration. So that means if you push a change inside the Git repo, it's going to be reconciled and it's going to be brought down into your cluster. You have an increased visibility of the changes, usually by pull requests. So you know what is going to happen. You can have gating or by having approvals. And you know with the history of the changes, what happened in your cluster. So similar, if you want to do a rollback of something, you don't go on your cluster, do the rollback manually. You're going to just change the version number, going back to the previous version, commit push, and the pipeline is going to trigger and do everything you want. And one of the other thing is you can manage multiple environments from the same source. So with GitOps, one of the problems you see that I show on the previous pages there, if you want to deploy to another environment, you need to have a similar pipeline with a different set of configuration and then calling your API, which is not great. Where that you can have either a central operator in one cluster, which is talking to all the others, or you can have the same operator deployed in multiple clusters. Cool. So GitOps is kind of a set of practices. There's multiple implementations. So last month we had a presentation on Argo CD, which is one of the implementation of one of the operator doing GitOps. Today I'm going to talk a bit more about Flux. So I've been using Flux for about a year and a half now. And what is Flux? Essentially, it's a CNCF product, same as Argo CD. It's been released recently in their version 2, so they're going to communicate probably a bit more about the product. And it provides a set of specialized tools and Kubernetes controller, which are doing a few things. They are pulling the changes at high level. They are pulling the changes from your Git repository, checking what is happening in the cluster, reconciling what is in the cluster, and potentially notify that there's something that happened. So it's kind of a toolbox. You can use whatever you want with this. You can use pretty much as I'll show some of the tools. So there's a bunch of components within Flux. So you have the main one. You have the source controller, the customized controller, the hand controllers, which are there. So that's kind of the high level. So each of them, the source controller. Let's see if I can move this somewhere. So anyways, the source controller provide a bunch of CRDs which are there to essentially download the sources. So you describe within using a CRD. Who's familiar with custom resource definitions? Should be pretty much everyone. Cool. So it provides a bunch of CRDs which it's going to listen to and going to be able to download. So you describe your CRD with, let's say, I want a Git repository, or I want a Helm repository, or I want a bucket where I can upload or download some stuff. And then the controller is going to look for what is changing in these things. So pulling every 5 minutes, as an example, or every minute, and then downloading the artifact that is then going to be consumed by others. Then you have the customize. So within Flux, there's a huge use of customize. Yeah. Good. So with the customized controller, so we give a path to Flux, which is then going to look at similar. So you'd say where it is, the reference to, as an example, to your Git repository, where it is inside your Git repo. And then it's going to pull the changes from the Git repo and then try to build the customized version of of your manifest as an example. I'll go in detail about this. Then you have the Helm controller, which is doing something similar with Helm. So it's going to pull the Helm charts and then apply the release that you describe in Helm. So you can specify the version, you can specify the values you want to apply, and then it's going to build the Helm chart and then deploy it in your cluster. And finally, you have, I mean, there's two more. There's the notification controller, which is, you can do two things with this. So you can either trigger some messages based on event happening inside Flux. So as an example, when you have a version that's been reconciled or a new version of that is available within a Helm chart, it's going to trigger a message, and you can send this message to, as an example, Slack. So you will have a list of messages coming in saying something is available. And equally, you can do something the other way. So you can have a webhook as an example, like GitOps. So if there's any changes within your repo, when you push your change, this is going to call your Git webhook, which is going to call your ingress, which is then going to call the notification and then trigger something from there. And then there's one thing, I haven't really used it, but there's also a controller to manage images. So it's able to, when you push an image, to reflect the changes of the image within your templates or within your manifest. So if you upload an image to, as an example, in Docker, it's going to pull what is the changes. And when it detects that is something that is within the boundaries you want, it's going to update this within your manifest. So patch to your manifest, git commit push, and that's it. By default, it doesn't come with a UI. So you have a command line to do pretty much everything. But there's been a UI that's been developed by which you can deploy on your cluster. I haven't used it, but if you like something visual, you can do it. So how do you start with Flux? There's a bunch of ways of doing this. So either you do the hardcore manual thing where you deploy your controllers, you deploy your CRDs, then you create a Git repository, you create the secret to access the Git repository, and then you commit everything. And hopefully, if you've done this well, Flux is going to take over and do this for you. Or you have two other ways of doing this, which we're probably going to, if I have time, going to go through this. So the first one is using Flux Bootstrap to bootstrap the cluster, which is going to do exactly this, but in an automated way, so less error prone. And if you use Terraform, you can also use their provider to do the same thing. Cool. So demo time. Let's see how bad it goes. Doesn't start well. Right. All right, so I have my cluster. So I have set up a couple of clusters. Is it a bit too small? Yes. Okay, so I'm connected to one of my clusters, and I'm just going to show a bunch of things. So it's a fresh cluster, a couple of nodes. There's nothing much running on this but the bare minimum. So what I've done is I've installed on my machine the command which is flux, which provide a bit of everything. What I have is I have a Git repo that's is available here. It's a private repo. I've already pushed a bunch of things for the demo, but what is important there's you'll see things appearing in this. So let's start. So first thing is we need to bootstrap the cluster. So what we need to do is tell where the Git repository is, what is the branch we want to commit something, and the name of the cluster that we want to do. So one last thing I forgot to show. If you look at the CRDs, there's just the bare minimum from the fresh cluster. Cool. So this is going to clone somewhere on my machine the repo. It's going to generate the manifests for my cluster, and it's going to push the changes. And it's going to generate an SSH key that I will then need to add to my cluster, to my Git repo. So let's do this now. So it generates this SSH public key that I'm just going to add to the deploy key. So if you do this using the bootstrap, that's the one that you need to do manually. Okay, so we add the key. We authorize this thing. There you go. So if we go back to the code, now there's a new entry. Let me see. There's a new thing which is cluster lab OVH and the Flux system, which contains a bunch of resources. So I'm just going to finish the bootstrapping. Okay, so it's pushing the changes, and then it's applying the manifest inside the cluster. And now what it's done is it configures itself to look for Git changes to reconfigure itself. So it's kind of chicken and egg problem, but with the bootstrapping, you create this, and then from there you can manage everything using Flux and the same approach you would use for anything. So let's have a look what's been created. So we have now a new namespace, which is Flux system. There's a bunch of things that have been deployed. So you have the Helm controller, like I said, customized notification and source controller. They're going to do a bunch of things. And if we look at the CRDs, there's a bit more. So now you have a lot of them related to Flux. Cool. So that's all good. So we have our cluster. I'm just going to pull the changes. That doesn't sound good. I guess you're not allowed to do any SSH on the Google Wi-Fi. That's going to be fun. Um, hmm. That's not going to be easy. Well, the demo gods are not with me tonight. um, it's going to be hard. Cool. Yeah, there's a bit of a lag on the for those online. Yes, better. Cool. So I've downloaded the components. So what the Bootstrap function did is it created a customize, which look at two different things. So it deploys creates the namespace, create the policy, the network policies, creates a bunch of things, deploy the roles, everything. So that's all the description, everything you need to deploy your cluster. And the second thing is it's creating the first resource, which is, in that case, the Git repository, which is saying, go and get this over SSH and use the main branch and use the SSH private key that's been created and provisioned by them, by the Bootstrap. And then once you have the demo, the Git repo, which is named Flux system, you then reference this this within your customization, and we just say, go and check everything that is in this directory, and if you find anything, apply it, reconcile it. And it says, use this Fluxcd Git repo, which is within the same namespace. Makes sense? Any questions so far? Cool. Cool. So what we're going to do now is copy. So I've created, I mean, not necessarily me, but I have a bunch. Does it work? Yes. Cool. So I'm going to go into my cluster. So I've copied a bunch of files. So if you look at the status, so there's a directory called app, and there's a file here, which is my application. So what I'm saying is look at the Git repository and then go from the Git repo in this directory. And then because it's a customization, is going to look for the customize.yaml and then trying to do what it needs to do with this file. So if we open the customize.yaml, we have something which is creating a namespace. We have another resource there, which is going to create a Helm repo. So it's just describing, here is the source of my repo. And so there's the URL and says every 5 minutes, you're just going to pull any changes coming in from this repo. And then we have, because it's a Helm chart that we're going to deploy, we're just going to say, this is the name of the thing, pod info. Go and pull it from this from this Helm repo and just doing some customization. So I'm going to change the values and say, I want to have this version. Why? Because I want an old version and we will just do an upgrade later. So what do we need to do? Simple. Add everything, push it. and then we should wait. At some point, we will create, so that's what is there at the moment. And at some point, we should see another namespace. The main problem with what I've just done is I can wait 10 minutes. Because if I'm lucky, I might just wait 30 seconds, but it might take more than this. So what I'm going to do is force manually using the command line, the reconciliation. One thing I forgot to show is this is all the resources that have been created and are viewed by Flux. So I'm going to reconcile my source, my Git repository source, which is then on the next run, you will see what is happening. What happened is, did I push it? Sorry, commit. So, yeah, if you don't commit, that doesn't work. So add the pod info manifest, push it, force the reconciliation, and we'll see a couple of new resources popping up in this. So the first one is the Helm release. So the Helm repository, which is saying where this thing is. And then we have the Helm release, which is coming from the customization of the pod info. And you see that there's a bunch of information there saying that this is the reconciliation is in progress. So let's wait a bit. That shouldn't take long. And voila. You have your, you can see now that you have a new namespace. And there's a bunch of resources that have been deployed, mainly the pod info itself, the service, and so on. So what I'm going to do is just to prove that it works, is just forward locally on my machine it's forward the ports and show that it's working. There you go. So that's simple. That's how you deploy an application. So very simple. Now, how do you do an upgrade? Well, similar. You copy, you just change. So in my case, I'm just upgrading the tag. So if you see here, the version is 636, and I'm just going to upgrade this. So commit, push. Pause the reconciliation. Okay, it's restarting recreating the pods, and I will lose my connection, so I need to restart it again. And voila. Upgrade, done. Cool. So what else do we want to do? Well, Flux is very powerful. You can do a lot of really cool thing with this. And one of the one I like the most is, or one of the features that I like the most is the fact that you can use environment variables and inject some variables inside your manifest. So why would you do this? Well, you can have something that is generic, and you can then pass it on to your multiple clusters. And if you use some convention within your clusters, you can automatically create resources for you. So let's just do this. So what I've done is I have defined within my release, I'm just saying I'm going to call this variable, so which is $, the accolade and the name of the variable. And if there's nothing, I will just default it to blank, which is going to be then removed. And within my, let's go into this file. So within my customization, I'm just going to say post build, you're going to substitute this value or this variable with this value. So what is going to happen is the customization is going to inject those variable inside the application or inside the manifest, and then submit the manifest to Kubernetes. So let's have a look. Okay. So what is going to happen is you will have a different greeting and a different color. Let's reconcile this again to make sure that it's happening. Okay. It's upgrading. Cool, and voila. So this is great. So I said that one of the thing with GitOps is when you make a change inside your resources, GitOps is going to, I mean, the Flux and all this thing are going to reconcile the changes. So making sure that it's, if you have a value there, it's reflected over there. This is partially true. Because in this case, we're using Helm, and there's no, by default, drifts, or there's no way to detect that there's been a change. So if I do something like this, edit my deployments, and so this is what's been created. So if I do something like this, August 2023, save it, it's going to redeploy. There's nothing in Flux which is going to change this until I change the version or I make a change inside the Helm chart. So how do you go about this? Well, they released a kind of beta feature which does exactly this. So simple. What we're going to do is just say to the patch the controllers. So the configuration that is generated by Flux itself, we're just going to patch it and just enable the feature gates drift detection. What it's going to do is then it's going to check if the values that's been applied are the same as the results. And if there's any changes, it's just going to force the reconciliation. Forcing the reconciliation. Flux is going to restart itself, and it's going to apply the changes. And that's going to revert the changes I made manually. So that's one of the cool features. There we go. So I haven't changed anything in my code. I've just said detect that there's a drift in the configuration, and it reverted my manual change. So that's one way of doing this. Okay, do we have a bit of time, or how are we doing for time? Because we can do something a lot more cooler. So I have a Terraform script, which I don't know if you've seen with the variables. So here I'm injecting some variables, but there's another way of doing this, where you can create a configuration are either a config map or a secret, which is then going to be injected inside your application, and then you have those data. What I'm going to do, I'm going to create the secret. From here, so I have a bunch of convention that I'm using. So I have the name of my application, the domain, what I'm going to change, the data center environment. So that's just for the name. And what I'm going to do is just going to configure external DNS. So allow external DNS to, because we're going to, the idea is to deploy an ingress to put the pod info online and show you that you can access it from the outside. And so what I'm going to do is just inject all those variables from within this, and I'm just going to create a Cloudflare key, which is going to allow me to do SSL let's encrypt with DNS resolution, and also create the domain that I need. So that's going to create everything, and I'm not going to show you the secrets that is resulting, but it's just something very simple, a simple secret. So what we're going to do is going to deploy Set Manager. So this one is a bit more complicated. There's a bit more moving parts, because when you deploy a controller like Set Manager, you need to deploy the CRDs. If you don't have the CRDs first, then you start having some problems. So what I've done here is I've just changed a bit the structure of my cluster. So I'm deploying a few resources. The first one, so if we look at what we have in the core, we have the components, which is my description of Set Manager, the CRDs for Set Manager, and I want to centralize Helm chart repository description for all my resources within my cluster. So that makes my life easier to manage. It's easy for me to manage. Devs can consume it if they want, or they can deploy their own. But like this, there's only one resource inside my cluster. And then there's another cool feature within this, which we're going to see right away, is same. I'm just saying where this thing is. And we are going to play with something called dependencies. So what we're saying here is we're telling Flux to do something after, in that case, the course here is been created, the Helm repos have been created, and then we can start deploying the Set Manager controller. And then what we're going to do is create a bunch of issuers which are going to be created after my controller has been created. So you can start having some sequencing in terms of what you want to deploy, and you can play with these sort of things. So what do we have? One thing I forgot to, so I don't know if you see there's some dependencies. So this one is dependent on Flux core CRDs. The manager is here is depending on the Set Manager controller. And until they are coming up as ready, it's not going to do anything. So that might take a bit of time. Sometimes it takes a couple of minutes. There's ways of speeding up the process by changing some, tweaking some values inside Flux, or inside the controllers. So you have your, right now it's reconciling. It's going to take a couple of minutes. While it's doing this, let's just have a quick look at there. So what I've done there is I'm injecting my secret that I have created previously. And how I'm going to use this, it's by going inside my issuer and injecting my token here. Is it the most secure way? No, definitely not. I'll probably not use it in production. I would use something else, but that's some of the thing you can do. So the secret is in the Flux system namespace. It gets injected inside your set manager namespace, and it creates the secret there that is then used by by set manager to do the DNS authentication or DNS key for the set manager. How is it? Boom! Everything has been reconciled. So that is the first step. So last step. So I have now set manager that is deployed, which is using this, and I'm just going to deploy an ingress, which is going to do all of this. So what it's doing, I'm deploying external DNS to create the link dynamically, the link inside my zone, the ingress, a couple of resources for this. So again, deploys the CRDs first for external DNS and traffic, deploys the Helm repo, and it will then configure my traffic controller and my external DNS. So same thing for the external. I'm just going to commit push and show you what's. It will take a bit longer. So again, we see there's a bunch of errors, but that's fine. They're going to be cleared at the end of after multiple reconciliation, it's going to clear itself. So again, you have this, which is waiting for the CRDs to be deployed. It's waiting for a bunch of things to happen. So what did we do in my components? So similar to this one, I'm saying go and get the key that I have also injected. And what I'm doing here is I'm adding I'm injecting some of the data. So like the environment, the name of the data center. So like this, I can have keys within my zone, which allows this to not go in conflict with each other. Okay, few more minutes, and now I've also changed the pod info. So if we look at the pod info variable, I'm injecting also the secrets, and I'm adding a dependency to my core components, which is containing my ingress. So what is this going to do is on my application, so similar as earlier, you have this, but what I've done is I'm creating an ingress using my traffic public entry, going to generate these Let's Encrypt certificates, and it's going to have the name pod info, the name of my data center, the environment, and the name of my domain. And it's going to also create my TLS thing. The dependency, it takes a bit of time. It takes a couple of minutes it's waiting for the next component to be ready. So that sometimes can take a bit of time. While it's reconciliation, do you have any questions so far?
Where is it for creating container images?
Which container images?
You've got like these pod info. Is there a step in there where it creates container images?
No, not in this demo. So the content, I'm assuming that the containers are already there and are already inside a Docker repository or an OCI repository. There's multiple ways.
ideal ways of securing your, what are the ideal ways of securing your secrets? Because with Flux or even Argo, if you commit your secrets in the repo, it's not a great idea, right?
Yeah.
So right now you have to the documentation, so you get access to secrets, but it is not this that is also not a security. So what's the better way to actually do this?
So you would use external secrets.
Yeah.
I don't know if you were there last.
Vault or something.
Yeah, HashiCorp Vault or external secrets. Yeah.
But how do we integrate that with Flux?
So you would deploy the controller. And in the case of external secrets, what I do for my clusters is I'm creating a cluster, a secret cluster. I forgot the name. A cluster secret store, which is then referencing my the place where I want to put my secrets, and then I'm just injecting or telling it, creating the resource here. So I'm the same process you do with external secrets. One more run and we should be good. Usually it doesn't take that long. Any other questions? Yeah.
We can also set environment for different kind of environments you can set in. So like for staging, we have a different kind of thing, and for production, we also have different kind of thing. So usually we set two different CSV when we push any changes into it, we actually trigger before the parallel, it then get executed. So how this one makes it like us?
So you would need to have the environment variable outside of your cluster. So let's do another. That's great. So there's another thing. So I'm just going to quickly. Yeah.
Sorry about the breakup. Fortunately, our second speaker will have to begin our talk now, and we have more questions for Yann. Hold off till after our second speaker. Thanks so much for understanding. Yeah.
All right. Thank you.
Sorry, small piece.
Cool. Yeah, that was just wrapping up on what we've seen. So so far we've done all of this. So bootstrapping deploying a simple application, updating the application, configuring the config drifts, and using the environment variable and so on. And then the last piece I was going to show is doing the same thing with the Terraform controller. And just to answer your question is I will inject different environment variable and then same place I will just inject the environment variable. So I do not change anything in any of the configuration. It's just the variables which are different. And then there's a bunch of other things you can do. So if you're interested in playing with Fluxcd, there's a good getting started guide, and also this is a good resource. The Nane Dev, where you have a lot of examples of people using it at home. So you have a lot of the template that I've been using. I pull them from there. So don't reinvent the wheel. Go and check what is available there. And there's a lot more things we can do with this. Cool. Thank you.
Hello, hello Kunal. You're not connected to audio. I can't hear you. I can't hear you, Kunal. Could you just connect to audio so we can hear you?
There are regulatory reasons, I'm not going to lie, but majority of the times there are ways that you can actually go to different regions and grab resources there. And that's where a platform like GKE Autopilot comes in. Anybody knows what GKE Autopilot is? It's good enough. That's one. Anybody else knows what GKE is? All right, lovely. Let me give you a 2-minute spiel on that while I bring this up on the screen. So there are two modes of operation with GKE Autopilot. One is two modes of operation with GKE. One is Autopilot, the other one is standard. Standard is really just a managed service, Kubernetes service, wherein the user manages everything, nodes as well as master. On GKE Autopilot side, the only thing that the customer needs to really care about is their pods, is the application that they deploy.
right? So on one side, you're paying for the capacity that you're using, that you're deploying, which is the nodes, all the CPU, memory, hard drive, whatever you're deploying with that. And on the other side, all you care about is a pod. So you're moving to more of a serverless pod. The obvious question is that why don't all the people use Autopilot? Because they're silly. No, I'm kidding. What happens there is that standard is obviously a cheaper option. Like if you know what your demand is, if you know how many users are going to ask you for this, what is the request pattern that is coming in, it makes sense to use that. If you don't know that pattern very well, it could be overnight. As an example, one of our customers was saying that they do insurance, ticketing insurance, and their busiest time was when Taylor Swift did a concert in London. And that spike happened overnight and it came back to zero because they never did any selling after that. So it's things like that, that demand is just not deterministic. Even if you deploy standard cluster there, how do you know how much you do? So you do pay over this a little bit when you use Autopilot, but it makes sense. It works out. So what we're doing here. Oh, sorry. I'll grab this. Does that work?
Yeah, sure.
So I lost my thought.
Sorry. Tell us the concept.
I can sing if you want. Yeah, so what happens with Autopilot is that you really just paying for the cost, whatever you deploy, and with standard, you're paying for the full capacity of the nodes. The second thing, I'll actually show you guys this as I talk to it. I'm actually using a little bit of GitOps, by the way, Van, but unfortunately, I'm not using Flux. I'll start using better tools, I promise. Okay, so this is the cluster location. I'm just creating Autopilot clusters, as I said, 8 clusters. So you've got 8 locations that I'm using, and I am using Terraform. If I can find where it is. And in main, you can see that I'm just iterating through the, can everybody see that? Yep. I'm just iterating through those locations, adding a GKE, appending GKE to each location and just creating a new cluster. So you'll see all these are GKE clusters. Now what I'm doing there is I am deploying something called the stable diffusion guy, which is this deployment. Like nothing super special here. It's just I'm calling out that I need a T400 GPU. A100 is the other one that I was talking about. They've been sold out for a long time. And that is the Docker image that I have packaged and created with all the 4 components that I highlighted earlier. And I'll just deploy that. That's again the extra request that you need there. I'm very, very conscious that I'm flying through this. Are there any questions?
Data diffusions, both training and prediction are fun. I'll just speak loud. That's okay. Okay. So first, both training and prediction are sort of spiky in nature, right? And with GKE Autopilot, they spin up resources and spin down resources every time you are predicting something.
Yeah, great question. So what happens with Autopilot is that Autopilot is not based on a request. That is a true serverless model, which is what you get with something like Cloud Run, Cloud Functions is the other way of doing it, where nothing is actually there. The service comes or the request comes in, then you wake up the infrastructure and serve that request. So with Autopilot, it's a conscious decision of actually deploying the infrastructure. Right, so you explicitly make sure that I want to deploy my application in a certain region. So you might have a cluster sitting there, it's sitting there doing nothing, no one's getting charged, globally losing money. But as soon as you deploy something, that's when you start getting tired. Right? Two separate things. You're deploying the cluster sits there idle. And now you deploy workload on that cluster. Workload being something like this. Yeah, that's when you start getting charged. As soon as you take it off, the charge goes back.
So what does it scale? So what's the basis for scale up?
So the basis for scale up is really just a unit called pod.
Okay.
So you just
deployment.
correct. If more requests come in, if 10 requests, you say that the threshold is 10 requests. If it hits 9 requests, I don't know the exact number, it will scale out in minutes. It's horizontal scale.
If there's no traffic, it scales to 0?
Not on Autopilot, but you have explicitly made a decision to deploy. Like in a true serverless model, which is Cloud Run, it will scale that.
Are there any limits for Cloud Run, and is there a cold start problem?
There is not the cold start problem is classically for things like I'm not having a go at the programming language by the way, but something like Java, which just takes time to start up. But you're actually literally starting up a service, right? So that's the cold time that you're talking about, whatever time it takes. But even with Cloud Run, there are things like minimum instances. You can say that I can have a minimum of 1 or 2 lines of code.
So there's a limit, right? You can't like run GP tasks on that. It auto cuts off.
Can you say that again? Can you please pass on the mark? Because that's a very, very important.
There's like limits in cloud functions, right? It auto cuts off and kills the function if it's like.
Oh, no, sorry, that's not true. But the GPU part that we said, that's 100% true. There is no access to GPU. The piece around what you said was the request timeouts and everything like that. There is a really long timeout period in the sense that there is something like, I'm again going to get this wrong, something like an hour or 2 hours that it can run for, and after that it goes away. But if your request is running that long, you're better off looking at something like a job as opposed to running it in the cloud. But that's a little more. There's someone at the back.
They have a Zoom attending of that, so we need to put that.
Give me a step count up.
So with respect to the management pods, like you said, like there are workloads that you charge, Autopilot charge you when you deploy workload.
Yeah.
So there are management workloads that we run. So those also counts like what are the separation, what are the kube system pods or only or the any kind of a management workload that we run counts to the Autopilot trigger.
Can you give me an example of the management?
Let's say we'll be running Argo CD.
So Argo CD is a workload that you have explicitly decided to run.
Okay.
So for you, it might be a management workload, but as far as the service provider is concerned, it's a workload that you run.
Okay, so whatever that we configure on as part of our deployment is considered a workload for us.
Correct. If you make an explicit decision to go kubectl apply, you're going to. All right, cool. So what we are going to use, or what we have used Autopilot here for, is that I'll show you in a sec. The GPU resources are really scarce. So what I've done is that going back to this bad boy, spun up clusters in 8 regions. What I'm hoping is one of those regions has an available GPU that they can spare from, right? I have had this cluster running, or these clusters running since this morning. So I have been able to pick up 8 in all these regions. But what I'll do in a sec is that I'll actually try and deploy one more, one of the other GPUs, and you'll see that all of these goes red. And then it's just a matter of time, right? To say that when is one of the GPUs available, I'll pinch that GPU, and I'll start the service. But that is non-deterministic. So we'll be just waiting around for almost forever if it doesn't come. That's why I want to show you a working copy first, and then we will break the thing. Now, other thing that you'll realize is that this is the actual deployment. My deployment specification doesn't have a service in it, which means that I can't expose that service to the outside world. Make sense? You've got 8 clusters. You've got 8 instances of the application running. But so far, what I've shown you is that those 8 instances are isolated. No request can hit that world or hit that application. With me so far? So that's where multi-cluster ingress comes in. I'll see if I've updated this thing. And I have. There you go. So what multi-cluster ingress allows you to do is that it allows you to wire up resources, applications, services that are sitting in different regions, different clusters. We have got the identical application running in 8 different regions, potentially 8 different regions. We don't know, right? 2 of them might not be up, so that might be only 6. So that the backend, if you like, of those services can go anytime, especially if you're running like a spot instance or something like that, it can go anytime, right? So you need the front end to be intelligent enough to do a health check on the back end and pick up the right application for you. Is this making sense? The next thing what we need to do is that we need to be able, sorry. Yeah.
It provides only one virtual IP, so it must be backend solved to check that.
Say again, sorry?
For server, we only have one IP. Like here, a single consistent virtual IP for add. Independent app of where the app is deployed globally.
Correct.
We only do have one IP. So
that's correct.
So all the other things must be handled by the backend.
Correct. But one external IP, right? One for the world to find out. And the routing internally happens by the controller that Google has.
So front end must not take anything for the server side. Like you only need to send request to that one. Then
correct. So the front end being the client, right? The client will always send requests to that one IP, and internally will do the intermediate routing.
Will be similar to an API gateway, like where it aggregates all the requests and routes it according to the request.
Correct. Really, it is think of it like an API gateway. Really is the one more real play.
And if the control plane is the control plane in GKE serverless function or a running server?
Can you repeat that question again?
Is the control plane in GKE serverless function or a consistent server that we pay for?
There is a minimal cost with the control plane. Yes. I don't know what it is, but it's not much. What I'll do is that we'll keep going, but I'm very mindful that it's well past 7:30. So I just want to show you how the thing fails. So that's stable diffusion that I've showed you. One thing I'll show you is that I'll just bring up the deployment YAML again, just for context. So that's the deployment YAML that you've already seen. And normally what we will do is that we would normally deploy a service that goes along with it. So if you'll see that I've commented this piece up, but if we deploy this, we will have 8 instances of services running independently in those regions. Yeah, along with those clusters. And that's why I have not deployed it. So there is no service. What I'll show you quickly is what a multi-cluster deployment, multi-cluster ingress. I'll get that right one day. So this is the multi-cluster service. You'll see that the format of the spec is very, very similar. It's only these things, the multi-cluster service and the API version of the kind, that is different. Again, you use selectors to select which application you want that service to connect to. Excuse me. The service that the web UI actually serves that at 7860, I'm just redirecting to 80. And then as with any other model, this service will be serviced by a ingress controller. So this is the ingress controller. Oh, sorry, I'm bringing up service again. And that's the MCI ingress. Make sense? And you can see that I've annotated it with that IP address, that the DNS name is redirecting the request. Make sense? And it logs me out. Right, so what I want to do now quickly is go here and go to Stable Diffusion and go to deployment. And because I'm not as good as Yann typing with one hand, I'm going to use two hands. Just bear with me. Go here and we will change it to. So there was a way to edit these files here.
There's a code button on the right.
Does that do it?
To the right of you.
To go back.
Change the .com to .dev and then it opens the VS Code server.
Or click on that.
This piece?
No, on the URL.
On the URL?
Just change it to the .dev instead of .com.
All right. I'm not going to do that. So what I will do instead is I will go to my VS Code and change this. All I'm doing is I'll show you in a sec. Yes. All right. So what I will quickly show you first is that you'll see that these are all green, and very soon, hopefully you'll see that I have changed this. There you go. I've changed it from T4 to A100. And very soon, this is where I'm using the GitOps style of working, Yann. It will take a little while to jump in. I think I've configured something like 20 seconds for it to go and pull changes. So it will take a couple of minutes. But before you see all of that going red, any questions? There you go. Started that already. And what you'll see here is that unschedulable. That essentially means that it can't find enough resources. I'll get in there if you want and show you the actual error. But that just means that you're not able to get any resources, the GPUs that we want, that type, particular type of GPU. And that means that you're not being charged for it. But there is no workload running there, right? So the idea is that if I need it, I will bring it up. And it could be even smarter, right? Like once you find a service somewhere, there is no need to bring up the other services. And you can have logic there that the skills of the other services. And hopefully that goes red. There you go. Never been happier in my life that I've killed something. Any questions?
So it's like we cannot determine when we will get a resource, but we can hope once we get a resource, we should be able to complete our task.
Correct.
So it's not that it cannot be time constrained. It has to be something which has a longer window. Do we have kind of SRE? Basically, any service agreement like in this period of time you will get a resource. Nothing like
The period of time is month, I believe. So if you know, no, don't quote me on that. I think it might be even a year. So if you know that you're going to need GPU, you're going to train, I don't know, LLMs. Your best bet is to reserve an instance and nobody wants.
Basically, it's more of expecting it to be completed, but it's not a guarantee that it might be completed during.
Correct, but to be honest, like if your workload is spiky, if it is bad, if you don't mind if the workload completes this weekend or next weekend,
I know,
just
but
line it up.
at least there has to be a time frame where I can say that at least in this time frame I will be able to complete my task. Rather
If
than-
you think it's that important, pay for it and reserve the instance.
I don't know, but if we have a service, I was expecting.
I'm being facetious.
Yeah, I know, but like
You're right.
at least there has to be some kind of option.
Any other questions?
Sorry, I'm not trying to be disruptive, I just got a thing to kind so it's.
Okay, there you go. Autopilot can't help you there.
Always mine.
If no more questions, what I will do though is that, as I said, this thing is on GitHub repo, so check it out. I think it's fairly straightforward to deploy. One thing I have missed doing is actually I haven't sort of written down instructions to follow. I think it's self-explanatory, but hit me up and I'll complete that. And if no more further questions, we have been a very kind audience, so thank you very much. Appreciate your time.
Thank you. Thank you so much.
Thank you.
Thank you so much. And if we don't have any more questions for our speaker, feel free to come up to and we have the feedback tool if you'd like to participate in the slides. Thank you again to our speakers. Yeah, have a good night.